raise Ecology. It's the Rural Arts and Science Education project here in France. We're in the middle of France near Poitiers, and Thomas called NTH has come to help us to install with the students. We've been working all week. In fact, we've now come to the point where it's pretty much installed, and it's looking like this. So this is full of a mixture of water with waste, food waste, and also some manure. And we've kick-started it with some of that organic microbiome that's got all the good archaebacteria to make the methane. And TH, do you want to explain how the gas gets from the tank into the storage bag, and then how we can then use that for burning and heating potentially?
Absolutely. So for those of you watching at home who may be thinking of doing this yourselves, there's a couple of exotic pieces in this, but the rest is all local materials. So this is a black IBC tank. Most IBC tanks are white. I don't know how you end up finding two black ones, but Janice was writing from Pennsylvania. You found the holy grail of IBC tanks. Otherwise, we paint them black, and then that takes more time, and I end up getting really messy. But this is a black IBC tank, so it's going to block sunlight, and that means no algae will grow, which means that there's not going to be oxygen poisoning the archaeobacteria, the archaea methanogens, and it also is going to heat up because black makes
it's already quite
so it's
warm.
always quite warm, and these want to be at about body temperature. So it's a local IBC tank. All the pipes are local. You've got a 100 mil pipe going down into the bottom with a cut knit on that side. The exotic part there is a 5-inch diameter flange, 4-inch uniseal, and it's a Schedule 35 uniseal we got from Uniseal Warehouse. So it's a 4-inch uniseal, it's got a 5-inch flange, you need a 5-inch hole saw, so we put that in. There's another exotic part here, which is a Schedule 35 2-inch uniseal. It has a 3-inch flange, so you need a 3-inch hole saw for that. So we had the 3-inch hole saw, 5-inch hole saw, and we have the 2-inch uniseal and the 4-inch uniseal. Again, Schedule 35, not Schedule 40 for France, because you got thinner pipes. This is a 50 mil pipe, and the 50 mil pipe needed a coupling in order to fit in the uniseal gas tight, and that had its own what they call a swage, where the pipe bows up a bit, so we had to make sure that the swage part was forced into the uniseal. Then we're coming up on that about 20 centimeters, because biogas tends to produce about 20 centimeters of water column pressure, so we came up 20 centimeters there. Actually, we decided to make the overflow the 20 centimeters, and then we put that about 5 centimeters higher, so that the flow would be when you feed it, the liquid fertilizer would come out here. It's got a T, it's got a 14 centimeter pipe that goes over the IBC, and then an elbow dripping into the slurry containment bucket, which can be used then to fertilize the garden. Those are all from here. The bag is a B Energy biogas backpack from Katrin Quetz out of the Eifel region of Germany, and you can get those online from benergy.com, as you did. So that's exotic to here, but you could use an air mattress. You could have used a truck inner tube. Yeah. This is nice and big, and it'll store, I think we're on 1,000 liters, right? Which is about the same size as this tank. And you should know that if it's a really hot day and you feed it a bucket of food waste, about 20 to 25 liters of food waste, this could produce up to 1,000 liters of gas in a day. That's the max it would produce. We're looking more probably at half filling the bag per day, 500 liters. Where the gas comes from is it's coming out of the lid to the IBC, which has a rubber O-ring. We haven't put anything inside it. We just carefully screwed it on to slightly compress the O-ring. It seems to be holding. Otherwise, we could have put some silicone or something. Another exotic piece. We got a 1.5-inch bulkhead fitting from Uniseal Warehouse, the same place we got the uniseals. They're about $4 or $5 each. And that we drilled a hole in the lid of the IBC tank and put that through. And then we had to get locally a 40 millimeter to 50 millimeter coupling, which we had to epoxy in, because there's no pipes that fit these American bulkhead fittings here in France. So it was a 40 to a 50, and where it had that swage is where we epoxied it in. Then we went into a 50 mil coupling, a piece of 50 mil pipe, all glued in, another coupling, and then unique to this part of France, we have a little screw-in cap, which we drilled through, and then we put in a 1/2-inch brass fitting that had locking nuts, and then we put a female to female piece of brass 1/2 inch, and this is just a common garden valve for your hose.
Yeah.
So nothing fancy about that. But this is usually the most difficult part of getting the gas out, making sure this is all gas tight. So we had to build that kind of specially.
Yeah.
You don't have big bulkhead fittings here in France. So that was specialty done, and that's it. There's just 3 penetrations to the tank. We use the I love you sign in sign language to teach people about it, because your fist is any tank, whether made of plastic, whether made of metal, whether made of clay, ceramic, cement. As long as you have a water tank and you put 3 pipes in, like even your septic tank could be made to be a biodigester because it's a water tank, but you need a pipe here that brings the food waste and the toilet waste all the way to the bottom, not dropping in the top like a septic tank is, so it's goes all the way down. Then you have a gas pipe coming out, and then you have the liquid fertilizer pipe going out that way. 3 penetrations in the top of the tank and you're done. There still is a valve down here if you had to drain it. So the way that it's working is, because we have these uniseals, we're overfilling the tank by that 20 centimeters of pressure. So there's water right up here, and that water seeking, so it's right up to here. Because we have that water up to here, we had to build this pipe a little bit taller, because this very thin half-inch pipe would get clogged with the floating material, and then you wouldn't get any gas out. So we're keeping this a few centimeters above water level so the gas can bubble through. If there's a problem, then you would have to blow back and clear that out. And this can open. That's the nice thing about this. If we had to, we could open this up. We put guy wires everywhere because we don't want any waggle, or it could then leak. These are just rubber fittings. So you don't want this thing, when you feed it, moving. So we've got, you see, guy wired all the way there. And when it starts making gas, you can hear it. If you can hear the bubbling.
Yeah, there's some bubbles. Yeah.
Right? You hear the bubbles. It's then going to put fertilizer out. When we feed it, and this is critical to know, every time that we feed it a bucket of fertilizer, and we're using a traffic cone so it doesn't get messy, we get the same amount of liquid fertilizer out. And this liquid fertilizer that's coming out is the fully digested material. Why? Because halfway down this pipe, which goes to the bottom, is a hole facing this way. Anything that's not digested, fats and grease that float, or solids, proteins and carbohydrates that sink, they're not going to get out this pipe, because they can only get out via a hole facing this way in the center. So they have to be fully digested to reach the buoyancy, neutral density of water. Fully digested before they can come out. Otherwise they're sitting there being eaten, or they're up here being eaten, and that guarantees that what we're getting out is the fully, or almost fully digested material. That one has a cut in it that slides the food in this direction, but it can't get out this way because it'll just hit the other part of the pipe, the holes on this side. So that's part of the internal design that we'll have to sketch for you that makes this thing work like magic.
I saw when the students were cutting that little rectangular piece out, so that's the gateway.
That's the gateway in, and then this out. You can afford to go from a 4-inch pipe to a 2-inch pipe, because as you're feeding, you're pouring in slowly enough that you're not going to overspill back on yourself because of this slight slope that's here. Not that the tank is sloped, but because this is a few centimeters shorter than that. As you pour in, it's going to start siphoning itself out. And that's a critical thing to remember. If this was sealed, if this was not open to atmosphere, it would create a siphon and it would suck the tank dry. I've actually had that happen, and the whole tank goes because the vacuum is very strong. Some people object to having this open because they're afraid of odor. There is none, but you would always put a pinhole. You've got to have atmospheric pressure break vacuum lock.
Yeah, so if you do put a lid on, put a pin.
Put a pin. But we keep this open, and then we use a plunger sometimes if there's a problem, if anything gets caught here. You can plunge there, and then if you have to, you might have to open this up at some point and clear out the scum that gets through. Here, the local parts, we always use clear plastic tubing because we want to see if condensate fills it up and blocks the gas. Same thing with this is clear. We have a 3-way valve here. We've got a T, and here we have a way of isolating the gas. We don't want to always reach up and use this, right? That's a hassle, and you might damage something. So you keep that open. You do your work down here to open or close. This goes to the kitchen stove. And this goes to the gas bag, which has its own independent valve down there. That can be taken, it's called a B Energy Biogas backpack, and you could just remove this hose and then pick it up and take it to the village, walking on your bicycle, on your motorbike, on the roof of the car.
So we could fill this up and take it to the and cook on it.
Yeah, cook on it elsewhere. That's how she designed it. Yeah.
So when we detach that valve, it's just an unscrew job, is it?
No,
And then,
no. All you would do.
Oh, do that. Okay, got it.
Yeah, you would take.
And then close the valve. Got it. The valve is closed already. Perfect. Yeah.
And maybe we should make a coupling that's easier to pull out. Maybe we should snip this and have some easy coupling.
Yeah, we could do that.
So you wouldn't have to go. Which might damage the.
You could have a yeah, but it might not be completely gas leak proof. There are easy couplings, but they weren't normally for water pipes. But yeah, we could do something. Yeah.
Figure something like that.
But actually, that's more direct. I kind of like that. It wouldn't be very often. It would only be when it's full. So it doesn't matter. It's not a hassle to undo that and take it.
And this could be put under there. It could be put up hanging from on the wall. There's a lot of options there.
Well, for now, we could even put it inside. We got enough length.
Yeah.
We could open that door and just put it inside. I mean, what I think I just want to, because this is a durable material, but if it's going to be out all winter, we don't want to leave it there. So we'll probably find find a better place for that. But that's great. I love it.
That's all there is to it.
Is this bag elasticated? Is that how it provides when it comes to being full and you want to cook on it?
It's going to be like a pillow. It's going to inflate like that.
Yeah. And then will it provide its own pressure out, or do you have
when
to
it's
press on
completely full,
There's
it will have it'll have enough elasticity that it'll produce the gas. But as it goes down,
No, it won't.
It'll lose it. And so people either put boards over it.
Oh, okay.
I use a throw rug because I think a throw rug is gentle on it.
Yes. Just
It
a
has
nice
the
big
weight.
rug just to
Come with a rug and just go. Bleh.
Woof. Yeah.
Literally throw the throw rug
it
on
only
it.
needs a constant flow. It doesn't need much pressure. It's
Right,
not
because
like,
we're not using a stove that has a restriction nozzle. We remove that from the stove. It's a wide open pipe, and it gets its oxygen from the point of burn, not from a venturi under the stove. So when stoves have venturis, you close those up.
You don't need the gas regulator.
No gas regulator, no open air duct at the bottom of the pipe. You seal that off with aluminum tape. You unscrew the restriction nozzle that has that little pinhole. You take that off. It's just a nice clean flow into the stove.
Great.
And if you need to, you can use an inline aquarium
pump. So that stove that I showed you, the round one with all the multi-hobs, that's probably the best one to use for this because it's not got any regulator. Yeah.
Right.
Okay, cool.
Yeah.
Wonderful.
That's it.
That's it.